Hello everyone. Hi, this is Shatarupa and welcome to Rasayanika. So hope you all are doing well. Okay, so before starting our today's session, I just want to check, am I audible to everyone? If am I audible to everyone, just type any comment in the comment section so that I can see and I can start. Okay, Aishwarya Lenka, yes ma'am. Okay, thank you Aishwarya for interacting with us. Just stay tuned. Okay, so today is our first live session for your upcoming CSIR NET examination, and this is the first session of our rapid revision rounds. Okay, so here I will discuss every day some very important question for your upcoming CSIR NET examination, and that will be very helpful for you. Maybe just stay tuned with us. So you have already know about that our upcoming examination in the 16th February, right? So there are mainly 8 or 9 days in your hand. So you all have very good preparation, right? Yeah, Papri. Yes. Yes, ma'am. Okay, so you all are excited? Are you all excited for the today's session? Okay, so let's start with our first question. Okay. So our first question is, consider the entropy changes in a system undergoing transformation as depicted in the diagram. The correct statement among the following is. So just look upon the diagram. There is a diagram in the question. And so which is the correct answer option? Option number 1 is delta S1 equals to delta S2. And delta S is not equal to the total, that is delta S1 and delta S2. Option number 2 is delta S1 is greater than delta S2 and delta S, that is total delta, is not equal to the each delta S, that is delta S1 and delta S2. Third option is delta S1 equals to delta S2 and the delta S total is the sum equal to the summation of each delta S1 and delta S2. And the fourth one is delta S1 is greater than to delta S2 and the summation of delta S equals to delta S1 plus delta S2. So just try to find by yourself which is the correct option. It is very important question for your upcoming CSIR NET examination. Yeah, basically this is coming from the thermodynamics, it's physical chemistry, right? So it's very important topic for you all. Just try by yourself. Aishwarya, option D. Okay. Rajrupa, the option D. Anurima, it's moderate, ma'am. Okay, fine. On email is, who can write the correct option there? So max of the student giving the option 4 is the correct option, right? You're going for the number 4, option 4. Okay, so I'm going to answer this question. Yeah, the correct option will be the option 4. Aishwarya, is you are very right. It's absolutely option 4. That is delta S1 is greater than delta S2 and the total summation delta S is equal to the delta S1 plus delta S2. Okay. So what is the approach of this type of question? How we can approach this kinds of question? So basically, if you have a very good knowledge or concept about thermodynamics, you can easily find out in your examination and you will not face any difficulty. You don't need to mug up the things. You don't need to remember so many things. Just you have to clear your concept and be cool, and you can definitely answer this type of question. This is very, very important and very, very conceptual question. Actually, and what is entropy? We all know that the entropy is a thermodynamic property, right? So thermodynamic property, which defines as the entropy, which defines mainly the disorderness of a system, right? So it is mainly, you need to know one thing, that when it is a entropy thermodynamic property, it's a kind of property that is a state function, right? You know about state function? You all know about state function, I know. That is, state function means the function which mainly depends on the initial state of a particular process and the final state, and that does not depend on the path in which the process follows. Okay, so entropy is that kind of state function which mainly depend on the initial state and the final state. It doesn't depend on the path of the function. So it is state function. So as well as you all know, the state function is entropy is an additive function. Okay, it is additive function. So you can do one thing here. That additive function means you need to just sum up your every entropy of each of every step. Just delta S total equals to delta S1 plus delta S2. Okay. Okay. So just look upon our question and the options. There is option 3 and option 4. Both option has the delta S equals to, that's a summation of both. That is, additive property follows. So just cancel out the option number 1 and option number 2. Okay. You can easily eliminate this 1 and 2. Now you have remaining 2 options, 3 and 4, and among these 2, only 1 will be our correct option. Okay. So now we need to find the each one, this delta S1 and delta S2, either equal or increase from each other or differs or whatever. So we need to consider these things. So basically, we all know that entropy is such a function that can be defined also as the heat, that is Q, divided by the temperature, which remains constant, that is T. So Q by T. Okay. So from this equation, we all know, we can also infer that this entropy is basically inversely proportional to the temperature, right? I'm clear to everyone? Okay. So if the temperature increases, we can say from this that if the temperature increases, the entropy will decrease, right? So just look upon our options and the diagram. Just look upon our diagram. There is a strict increase of temperature, right? So it is just increase from 25 to 50, then 50 to 75. So this increase of temperature is occurring here. So what the delta S will be? So obviously it is the inversely proportional, so delta S becomes decrease. Okay. So what we need to do? We know that the delta S1 becomes higher than delta S2. So which option is there? Only the option 4. Yes, absolutely. The option 4 will be the correct option, and all other options will be eliminated. Fine, everyone? Clear, everyone? Nirmal? Yeah, definitely option D. So many students are answering the good. That means a very great thing that you all have a very good preparation. Yes, just keep going. Yes, fine. Ashwarya, Anurima, Nirmal. Yeah, most of the students have given the correct answer. Yeah, definitely. Yeah, this is very, very important question. And this is mainly, it has come, I can't remember, mainly 2019 December net. Yeah, CSIR net. This kinds of concepts you need to follow so that you can answer in your question correctly in your examination, right? Okay. So just next move to our next question. Yeah, this is again from our thermodynamics also, and it is from our second law. Yeah. So the question is Cp minus Cv for a non-ideal gas differs from Cp minus Cv for a perfect gas by the expression what? They are given so many expressions in the options. Option A, that is del P upon del T at constant V into del U upon del T at constant S, that is entropy. Option B is del V upon del T at constant P into del U and by upon del V at constant T. Option C is minus 1 by T and del V upon del T at constant P into del U upon del V at constant T. And the option D is del P upon del T at constant V into del U and del T at constant P. Okay. So this is the expressions are given in the options. So you have to find, just find yourself by yourself, try to solve it, which will be the correct option. Anyone in the chat box who can answer this question? This is very interesting question. This is very, very important, and I can say it's very, very important concept is utilized here. So if you know the concept, you can easily solve this question. Anyone in the chat box? Just write down the correct option so that I can tell you that whether it is right or not. Hamad Kalkar, B or C? So Hamad, you are confused between B or C, right? But you need to tell only one. You need to answer only one in the question, in the examination, right? There are no options such like that you can answer any two options. Papri, she has written the correct option is B. Okay, someone given B. Anyone else? Any another option? Just try it yourself. It's very, very important thing, very, very important question. And it's this kind of question mainly asked in the CSIR examination right now. Okay, so let's find the answer. I just want to give you the correct option. So let's find it. Okay. So basically, we have given the Cp minus Cv for a non-ideal gas differs from Cv minus Cv for a perfect gas by the expression. Okay. So basically, you have been asked in the question, that is, you have to find the Cp minus Cv term, this one, for a non-ideal gas, right? And differs from, that means minus, that is, you have to take the subtraction form of Cp minus Cv for a perfect gas. Basically, you need to find the Cp minus Cp for non-ideal gas minus Cp minus Cv for an ideal gas. Okay, so what is the expression for this? You need to find these things like. Okay, so yeah, here our explanation here. So this is what I am said here, that we need to find these things. So all we know the one thing, you have all know in your graduation state or before that or whatever, you all know this, the for a ideal gas, right? Perfect gas means an ideal gas. So for an ideal gas, what is the correct value of Cp minus Cv? That is Nr for n mole of gas, right? We everybody know this. The Cp minus Cv value for an ideal gas is equals to Nr, where n is the number of mole and R is the universal gas constant, right? Okay, so now we also know that our perfect gas equation, that is our ideal gas equation, we all know that, right? That is PV equals to nRT, or when n equals to 1, we can write that as PV equals to RT. So basically this is PV equals to nRT. So just follow my trick. I am going to explain here a special trick here. It is a very quick technique which you can follow in your examination so that you don't need to follow a large derivation or anything. You need to it will not take much time in your examination. So just look carefully what I am going to tell here. So basically, you have PV equals to NR, right? just do one thing. Just keep the value. Just find the value of NR from this equation, and that is PV by R. Just keep it on your hand. Okay, keep it in your hand. That's NR equals to PV by T. Okay. So now we need to find the non-ideal gas. For this, the Cp minus Cv, right? So how we can find the non-ideal gas Cp minus Cv value? Okay, you can also derive this but you have also given so many derivation, you have all know that, but what is the problem is in your examination, you will have not much time to derive those things. So you must need to follow some easy technique, short kind of technique, which you can follow in your examination. So how we can write the Cp minus Cv value in this non-ideal gas? Just look upon this trick. So basically we have PV equals to nR2, right? And we have already nR equals to PV by T. We have kept this value. Okay, so now what we need to do, just Cp minus Cv equals to, where there for the non-ideal gas, just put those value, this nR value for ideal gas. For ideal gas, Cp minus Cv, there just put that value of nR in terms of PV and T. That is PV by T. Okay. Now we have to do one thing, just multiply T by both numerator and denominator. Okay, just like that. Just multiply this. Okay. So now we have the thing like that write down like this. Yeah, P by T, P upon T into V upon T and into T. Okay. Now how we can write this in terms of PV or derivation in terms of that for the Cp minus Cv for non-ideal gas? How we can write? Just look carefully these things. We have P by T already in our hand, right? P by T. So how we can write for this? We can write del P by del V. So we have our main parameters like pressure, temperature, and the volume. So here what is saying that pressure and volume is already written. So what is remaining? Temperature. So just keep it constant outside the bracket. Okay. Okay. So next, just move a little ahead. That is V by T term. Okay. So how we can write this V by T term? Again, in the similar way. So we can write this like delta V by delta T at constant what? Already written here V and T. Okay. So we have remaining the pressure terms. So pressure at constant pressure. And apart from this, we have the constant T term here. So just keep it constant here, T. Okay. So basically, now what we have got. Yeah. Yeah, now we have got this thing, right? This is for Cp minus Cv for non-ideal gas. And already we know the ideal gas value, that is nR. So actually, we need to find this thing. Okay? Okay, so let's find. Now, you know that in the option there, just look up on the option, there are no terms. Every terms is involved the internal energy U, right? So you need to find the option in terms of internal energy, right? Okay. So you need to remember just one thing, that is first thermodynamic equation of state. We all know this. Yeah, this is the first thermodynamic equation of state, which tells that del U upon del V at constant temperature is equals to minus of P plus T into del P upon del T at constant volume, right? So just from this, just look upon what we need to find, that is del P del T at constant volume into T, right? This term is here. Just look very carefully. This term is here. Okay. So what we need to do, just from first thermodynamic equation, just find the value of these things. Okay. Just like that. This. Just like that. Find the value and keep it. Okay. Now next, we will put it into the Cp minus Cv equation, which are going to we are going to find in this option, right? Okay. So this is what this is then. Just put I have just put the option, the value here. Okay. Okay. So just multiply one thing now with P and P, both multiply just, and you will get this equation, right? Okay. So now we are dealing with a non-ideal gas. So we need to consider the non-ideal gas equation. Okay. So I am writing here, just look it carefully, that is the non-ideal gas equation is P into V minus NB equals to nRT. Just don't be confused with the van der Waals gas equation. This is not van der Waals gas. So I have not been written here. Okay, it is perfect. Why I have kept here the pressure terms as constant? I have not introduced here the pressure correction terms, right? Because the pressure is kept constant here. So we don't need to confuse with the adding the pressure correction terms. We are only using here the volume correction terms. Okay. So just keep it as it and multiply this. So we will get this thing. Now what we need to do? Now we need to derivative. The first derivative in terms of temperature. We need to derivative it. For what? Because we have to find this kind. This parameter mainly. So how we will get from this equation? Just derivative it. So pressure is kept constant, right? So del V by del T at constant pressure. And so here all the terms are constant pressure, number of mole, B, everything are constants. So what we will get? 0 for the constant term. And for this term nRT, the T is derivating, right? So we will get the nR. So basically we got the value nR for this. Okay, so just put this value in the Cp minus Cv equation over here. I am just putting these things for the non-ideal gas like that. Okay, this equation. Okay, so look, this nR and nR will be cancelled out. Okay, so we have just this option. This is the correct option. See, which is the correct option here? Yeah, B, option B, right? This is our correct option. And thus you can follow a simple trick and you can easily solve a very large derivation or large thermodynamic equation or any kind of numerical such kind of that in few seconds. Okay, so this is very, very important concept for you all. So am I clear to everyone? Ma'am, please teach in Hindi also. Okay, Hamad, हिंदी में भी बोलने की कोशिश करेंगे. I hope you got my explanation. आपको समझ में आया? The derivation and the short technique. I hope so. Okay. So next, let's move to our next question. That is question number 3. Yeah. This is our question number 3. So this is mainly from our spectroscopy, molecular spectroscopy. This is also from our physical chemistry. You all know that the CSIR every year has a very good weightage of marks that comes from the physical chemistry part. So it's very, very important for you all to prepare the physical chemistry, and you should all should have a very good concepts of everything about physical chemistry. So this is a very important part that we'll cover here. So this is from our molecular spectroscopy, right? So the question is, the frequency of OH stretching occurs at 3600 centimeter inverse. We all know that OH stretching frequency is around 3600 centimeter inverse. So the OD stretching frequency when the hydrogen is replaced by the deuterium atom. So what will going to be? Okay, so would be the close to, you have to find the stretching frequency of OD value. Okay, so options are 3000, 2600, 1800 and 900 also. So which of the following option is correct? Anyone in the comment box? You can write the correct option and I'm going to tell whether it is correct or not. Rajrupa, very good explanation. Thank you very much. Hope it will become a very good session for you all. It will be very helpful for you all. Option A, Rajrupa. Anyone from you can answer this? It's a very easy question. Actually, you just have to follow a particular trick, a concept. If you know that, you can easily answer this question. हमद, आपको समझ में आ रहा है? आपको यहाँ पे OD वैल्यू की स्ट्रेचिंग फ्रीक्वेंसी बतानी है. OH stretching frequency is given here. the value, what will be the OD stretching frequency? Papri, this is the option C. Okay, so I'm getting different type of options. That is option A or an option C. Anyone? Any other options? So we don't have so much time, so I'm trying to explain this question. You can also follow this and you can also try by yourself, okay? So just move to our explanation. Yeah, so we all know that this is basically depending on our stretching frequency value. So what is the stretching frequency formula? We all know that. This is basically nu equals to 1 by 2 pi into root over, sorry, that's not working here. Okay, so I can write again here. Yeah, so nu equals to 1 by 2 pi into root over k by mu. So what is k? K is the stretching frequency, say is the force constant, and mu is the reduced mass. So from this equation, if you all know this equation in our basic 11-12 standard, it is not in our standard equation, is we all know this from our basic 11-12 standard. So we can find that mu is basically inversely proportional with the root over reduced mass value, right? Inversely proportional. And we also know that the reduced mass value, the formula of mu is m1 into m2 divided by m1 plus m2. Okay, we all know that. Are you getting my point, everyone? Am I clear to everyone? Hamad? Acha, Hamad answered 2600. It's confirmed. Okay, so he has given the option B maybe. Close to 3000. Okay, so what will happen? Just let's see. Okay, so we are talking about, yeah. So this is nu of OD by nu of OH. We need to find these things basically. So how we can write? So this is basically root over mu of OH by mu of OD. From this equation now, we can write this. So just put down the value, that is atomic mass of oxygen and hydrogen and deuterium, everything in this term, in this formula. We can write the reduced mass. What is the 16 into 1 upon 16 plus 1 divided by 16 into 2 upon 16 plus 2. And we will get root over 9 by 7, which is more or less approximately it's 2700. So we have in our options, it's more close to this, that is 2600. It's option B, right? Hamad, you are right, that is 2600. That is 2600 centimeter inverse is the stretching frequency. And you need to just remember one thing, not remember, actually you need to know this concept. That's when we replace hydrogen atom by a heavier element, any like deuterium or anyone else. So what is going to do? Because of this formula, this inversely proportional relation, the stretching frequency becomes lower. So when the OH, the stretching frequency was the 3600 centimeter inverse, and it is also obviously will be lower from that, and just you have to find the correct option in this way. Okay, so this is our correct option. Am I clear to everyone? Are you getting my point? Okay, so don't waste time, just let's move to our next question. Yeah. Okay, so our next question is correct order of molar extinction coefficient values of the visible absorption bands for the following species. There are so many options in given, where the option number 1 is hexa-aqua complex of chromium ion, which is greater than the hexa-aqua of manganese complex, which is also again greater than the chlorophyll, and that is also greater than the tetrachloronickel complex, that nickel tetrachloride complex. Okay, so just what happened there, the options will be jumbled here, and there are so many options. So which is the correct option among these 4? Anyone? Just try by yourself and type the correct option in the comment box so that I can see whether the option is correct or not. This is mainly what this question has been asked from our inorganic part. This is not physical. This is our coordination chemistry, right? Mainly coordination chemistry. So in our inorganic part, we can say the coordination chemistry is a very, very important topic which will cover a very huge marks in the question, in the examination. The some important topics from there every year in every session they always used to ask this question, that's this type of questions. The topics mainly coordination chemistry, the organometallics, bioinorganic, these are from the inorganic parts. This is very, very important. Okay, so this is also from this question, though it is from coordination chemistry, but I will say that it is asked in terms of somewhat in terms of physical. That is, you have been asked here the extinction coefficient, right? Molar extinction coefficient, this one. So anyone? Your voice is clear, ma'am. Thank you, Hamad. Ru, option 2. Option 2, that is, oh, that one. Anyone? Rajupa is saying option 1. Option 2 is answered. Ru is answered the option 2. Hamad, any answer for this question? Or Papri? Anyone else? You want to try to answer this question? Okay, so let's move to our explanation. Okay, so the correct answer will be the option B. Sorry. Yeah, the correct option will be option 2. So how? So just see, look upon the questions. So we have been asked that molar extinction coefficient, right? We need to consider the molar extinction coefficient. So what is molar extinction coefficient? If you know about molar extinction coefficient, it depends mainly what? On the absorption. Yes, basically the equation which may follow this, that is absorbance A equals to epsilon CL, right? So where the epsilon term is represented as the molar extinction coefficient and C is the concentration of the solution and L is the path length. So basically this is the absorbance. We need to consider things. If you find the molar extinction coefficient, you must know this equation. That is, molar extinction coefficient depend on the absorbance. So it is depend on the absorbance. So basically it is dependent on the molar absorptivity. Okay. So if we want to know the molar absorptivity, about the absorption, so just we need to consider about the intensity of the band. Okay, so just you have to think that we need to find the molar extinction coefficient. That means it depends on absorption definitely it will also depend on the band intensity, right? So if we want to consider the band density, what we need to find? Yes, we need to find the transition of electron, whether it is allowed or not, and if it is allowed, whether it is intensified band or not. Okay, so basically on that approach we need to find this. So what is the basic rule? We know all about the transition. That is, if the transition is spin allowed or Laporte allowed or not. So basically we just look upon our important rules, that is spin allow. If our complex is spin allowed transition, that is delta S equals to 0, spin allowed, okay, and also the Laporte allowed, that is delta S, delta L equals to plus minus 1. If both allowed, that is spin allowed and Laporte allowed, then the band we will get, the intensity will be maximum. The maximum intensity band we will get. So what kind of molecule follows this rule? Only the charge transfer molecule. Yes, CT complex, the charge transfer molecule follow this rule, where we all know the transition will occur from pi to pi star. Okay, and this is the spin allowed as well as Laporte allowed. Okay, so here in the option, just look up on the option there. Maximum stretching frequency would have which? That is chlorophyll. Only the chlorophyll in the given molecules, only the chlorophyll is the CT complex, that is charge transfer complex. Okay, no other complex are charge transfer complex, only the chlorophyll is the charge transfer complex. Okay, so just look up on the option number 2 and 4. These two should be our correct options, right? So just eliminate option 1 and option 3. Okay, so between 2 and 4, we need to consider which is the correct option. So again, our next rule is, if the complex, the transition follows spin allowed but not Laporte allowed. That is our second case. That is delta S equals to 0, that is spin allowed transition, but not Laporte allowed. That is delta L is not equals to plus minus 1. For which kind of molecule this follow? There are two cases. Two kinds of molecules follow this rule. One is a non-centrosymmetric molecule, that can follow this rule. Apart from this, for centrosymmetric molecule, that also follow this rule. Okay, so for the non-centrosymmetric molecule, what are the example mainly? The tetrahedral complex. So you need to remember one thing, that the tetrahedral or the non-centrosymmetric molecule show somewhat greater intensity of band than the centrosymmetric molecule. Okay, and the centrosymmetric molecule, which kind of molecule are those? Mainly the octahedral type. Tetrahedral means Ml4 type and octahedral means Ml6 type. Okay, we all know this. So just look upon our options and the molecules. Yeah, there is NiCl for 2- tetrahedral complex, and it is also and centrosymmetric molecule. If we show the transition, there will be you all know that splitting of the here the tetrahedral complex, that is E and T2 there, tetrahedral. So how many electrons are there? 8 electrons are there. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah, this is spin allowed transition. Here the electron can transmit from one state to another state, and this is spin allowed but not Laporte allowed. And so this is tetrahedral complex, and this is also correct one. And now again, just move to our chromium aqua complex. This is octahedral, and this is also what? Non-centrosymmetric molecule. Sorry, this is centrosymmetric molecule, and tetrahedral just centrosymmetric molecule. Yeah. So centrosymmetric molecule, this kinds of thing. What we have write to this, the electronic transition, right? Here the T2G and Dg, and there are how many electrons? Chromium, right? So there are 4 electrons, 1, 2, 3, and 4. So these are also spin allowed but not Laporte allowed. And the last, you need to remember the next rule that is the least, that can show the least intensity of band. Which kind of molecule? Yes, the molecule which has the either D5 electronic configuration or D10 electronic configuration. They will show the least intensity of band. So if we see this manganese complex, yeah, there is D5 electronic transition. Okay, so this is also not spin allowed and also not Laporte allowed. So yeah, our correct option is option 2. Clear everyone? Am I clear to everyone? Option 2 will be the correct option. Yes, then it will be centrosymmetric. Yeah, Gayatri, you are right. Hamad, I think you are getting my point. आपको समझ में आ रहा है, right? हमारे बातें. Okay, so just let's move to our next question. Yeah, this is again our from inorganic part, and this is from basically from our organometallics mainly. The question is, the most stable vanadium species in aqueous medium is, you have been given some vanadium aqua complex, and you have to find the correct option. Which one is that? Anyone? Muhammad Kalibullah? Yes, ma'am. You are getting my point. Okay, it's fine. That's very good. You all are getting my point. That is very good. That means you all have a very good preparation. Okay, just keep going this. What is the correct option for this? Question number 5. Anyone? The most stable vanadium species. Which is the correct option? Yes. So just don't waste our time. Just I want to explain this. I know you all know the correct option. Yeah. So just move to our explanation. The correct option will be which one? This is option 2. This one. Now why? You need to remember one thing when it comes to just about vanadium. Okay, so basically the most stable oxidation state for vanadium is +4. Okay, and the most stable form also you need to remember, that is that is oxovanadium 4 ion, or the vanadil. That is also called vanadil, oxovanadium 4 ion. So just look upon our molecules. Only the option 2 and option 3 have the oxovanadium complex. All other options are not oxovanadium complex. So we can easily eliminate option 1, option 4. Okay. So now what is the correct option of between 2 and 3? Now we need to consider the oxidation state. So see, here in option 3, oxygen is -2. Water is also, oxidation state is 0. So, and over there is +1 charge. So, we are getting vanadium, the oxidation state is +3 here. Okay. And next, for the, again, option 2, there also oxygen 2 minus, oxygen is oxide 2 minus, and there is also 2 plus charge over there. So, we can write the charge is, the oxidation state is +4, right? So, which has the correct option? You all know that now. All know that, right? This is the vanadium option 2. That's where we can get the +4 oxidation state, and this is the most stable oxidation state. So our correct option will be option 2. Option 2. Okay? So clear, everyone? 5H2O. Hamad Kalkar 3. No, Hamad, it's not 3. It's the correct option is the 2. Oxovanadium 4, yes, oxovanadium 4 is the +4 is the our stable complex of vanadium and show the maximum stability. And you need to find just the oxidation state. Okay, so just move to our next question. Yeah, so this is question number 6. Yeah, again it is from your inorganic chemistry, and this is basically from your group chemistry. Okay, so the magnitude of bond angle in gaseous NF3, that's nitrogen trifluoride, SbF3, that is antimony trifluoride, and SbCl3, that is antimony trichloride, follows the order. So which is the correct order? You need to follow this, and you have to say which is the correct option. Anyone who want to write the correct option? Mohammad Kalibullah, yes ma'am, thank you. Welcome, Mohammed, and thank you very much also. Okay, Mohammed is answering option 2. That is this one, right? Okay, option 2. Anyone? Fluorides have least bond angle. Fluorides have the least bond angle. Who is answering? Mohammed Kalibullah. Anyone from you can answer? Anyone else? Here I am seeing that Mohammed Kalkar, Mohammed Kalibullah, Papri and Rajrupa answering there. Anyone else who want to answer this? It's a very easy and very important concepts actually asked here. Okay, so let's move to our explanation. Which one will be the correct option, right? Okay, so our correct option will be option number 4. Anyone? In there is option number 4 answered? No, not yet. But Mohammed Kalibullah, you have answered the option 2, right? But this is not the correct option. The correct option will be the option 4. So now, why? Okay, so basically you need to know one thing here to approach how we approach this kind of questions in our examination, right? You don't need to mug up. You don't need to mug up this kinds of thing. How much you can mug? You can mug in the examination for your examination. You can't mugging up. So just you need to clear your concepts. Here basically have been asked from our basic concepts of VSEPA theory. Okay. So this is bond angle. We all know that according to VSEPA theory that whether the electronegativity increases for the central metal atom, then what going to happen? The bond pair will be more attracted toward the central metal atom, and that what going to be there? Then the bond pair repulsion will increase and subsequently and increase the bond angle. So basically with increase the electronegativity of central metal atom, the bond pair repulsion increase, which lead to increase the what? The bond angle. Okay? Okay, so this is bond angle. So we can write this bond angle is directly proportional with the electronegativity of the central metal atom, right? And also you need to know that bond angles are also inversely proportional with the electronegativity of the surrounded atoms, that is the atoms which are surrounded to the central metal atom. Okay? So bond angle basically directly proportional with the central metal atom and electronegativity of the central metal atom, and inversely proportional to the electronegativity of the atom which are attached to the central metal atom. Okay? So just follow these things and just look upon our question. So there are the three molecules, NF3, SbF3 and SbCl3. So which is the central metal atom among these? Nitrogen has the most electronegativity property, right? Nitrogen is more electronegative than antimony, right? So the first option, this NF3 would always have the the highest bond angle order. Okay? So you can easily cancel the option 2 and 3. Now among 1 and 4, you need to consider which is the correct option. Okay? So now consider the surrounded attached atoms. Okay? Because the central metal atom is same here, antimony, right? So now you need to consider the surrounding atoms. So the electronegativity of fluorine is greater than chlorine. We all know that, right? So what is going to be? We know from these things that is inversely proportional to the electronegativity of the surrounding atoms. So what will be the correct option will be NF3, SbCl3 and SbCl3. So SbCl3 will have the higher bond angle than SbF3, and also NF3 will the maximum bond angle among the all. Okay. So our correct option will be the option number 4. Now I am clear to everyone. Muhammad Kalibullah, fluorides have least bond angle. Yeah, he's also died that. I think I am clear to everyone, right? You all are getting my point. Okay, so let's move to our next question. Yeah, this is also from very important topic of your inorganic, that is going to be mainly the organometallics. It's very important topic, very important. Just go through this organic topics is cautiously, and because in your examination there are a lot of questions are coming from the organometallics. So our question is the cluster type of this iron. This is a cluster type of iron complex and also a cobalt complex are respectively what? Nido-nido or nido-closo, closo-nido or closo-closo, which is the correct option. Anyone would like to answer the correct option? First we see central atom, then the surrounding atoms. Yes, Mohammed Kalibullah, yeah, you are absolutely right. We need to first consider for your previous question, right? You need to first consider the central metal atom first. Their electronegative, check the electronegativity, and after that, check the surrounded atoms. Okay? Yeah. Papri, yes, ma'am, you're getting my point. Okay, good. So, which is the correct option? It's very interesting and very important, actually. Gayatri, the first one is nido. That is both are nido. Gayatri is answering the option A is the correct option. Anyone else? Okay, so just move to our explanation. The correct option will be option number 2. Gayatri, it's not the option number 1. It is option number 2. That is nido and closo. That is first one, it becomes nido, and second one, it becomes closo. Okay, now just look upon our explanation how we can solve this type of question. So basically you need to know to answer this type of question the basic 18 electron rule of the organometallic. You all know that 18 electron rule? Okay, so first you need to find the what? The ACP, that is a skeletal electron pair. Okay, so what is the formula? You need to remember this important formulas for this too. Otherwise, you can't solve this kind of problem in your examination. Just this is very important concept. So just go through this 18 electron rule. All the formulas for this very important for you. So ACP, how we can find? The formula is 12 into N. N is the vertices, number of vertices, minus of TVE. What is TVE? That is total valence electron, which definitely follows the 18 electron rule, and total divided by 2. Okay, so if we get, suppose X, we are getting X. So if the X value is N plus 1, that is number of vertices plus 1, then the structure will be what kind of structure? That is closure structure. If it is N plus 2, then that will become nido structure. It is N plus 3, then the structure will be arachno, and if it's N plus 4, then we call this hypo. Okay, so let's find the number of electrons, SEP, for this complexes. So for first one, just follow this. Yeah, just at first I find the total valence electron. Okay, so there are 5 iron atoms, and we all know the 18 electron rule. What number of electrons there in the iron? That is 8. So 8 into 5 plus 14 into CO. CO shows the 2 electron pairs, right? So 14 into 2, and this for nitrogen it is 5, and again there is a minus 1 charge outside over here. So we can just add this. So we will get 74. Now the SEP, that is TV minus 12 into N. So this kinds of thing. N means 5, right? You have 5 vertices. So divided by 2, you are getting 7. So what is the 7 represents here? N plus 2, this is nido. That is already you have 5. The 5 plus 2 is 7. So you are getting nido. So the next option, the next one, we will find that at first a TVE. In the similar way, in the cobalt, you have 9 electrons, just 9 into 6 plus 13 into 2, because 13 CO molecule there. Then 5 for nitrogen, and 1 for plus 1 for the 1 charge. So you will get 86. And now for the SEP, just 86 minus 12 into 6. 6, why 6? Because you have 6 vertices here. So you will get, by following this solve this equation, so you will get 7, and now you will get N plus 1, because your N now is 6. So it is N plus 1, that is closure. So just look upon the option number 2, that is this one, nido and closure, right? The option 2 is the correct option. Are you getting my point? Gayatri ma'am, I am telling for first one it is Nidhi. Ma'am, 3. No, Papri, this is not 3. Oh, it's nido. Okay. First one it is nido. Okay, I got it. Your point, Gayatri. That is, you are saying that for the first complex it is nido, right? Yes. It is definitely, it is right option. This is right, correct. You are correct. That is the nido. Okay, so I am clear to everyone, right? So let's move to our next question. Our next question is, this is for your favorite topic, that is organic chemistry, right? You all have a very good knowledge in organic chemistry, I know. So basically the question is, in the following equilibrium, conformer B is more stable than the conformer A, where R is, that is the group. So which is the group R here? So here in the option is methyl, fluoride, chloride, and methoxy. Okay, so which is the correct option? Anyone in the chat can write in the chat box. It is very, very important concepts has been asked here. Basically, you have to clear all the concepts about your physical, or whether it is inorganic or organic. Then you can answer this type of question. So Mohit Vaidya has answered the option 4. Mohammad Kalibullah answered option B. Hamad Kalkar is methoxy, option 4. And Gayatri answered option B. Papri also answered option B. There are so many options in the chat box. Yes. Hope you all are enjoying this session, right? Okay. So let's move to our explanation. So you need, before answering this type of question, you need to just consider one thing. You need to know one thing actually. In a cyclohexane form, if the groups are in the axial position, then the complex basically becomes less stable, right? We all know that. But in our question, it is asked that the B conformer is more stable than A. That is strictly, it is told here that this portion, The B conformer, where the groups are in axial position, are more stable than where the groups are in equatorial form. So when it is possible? Only then when there is such kind of stability factor like hydrogen bond. And here also we are going to show in this, so this kinds of thing, that is hydrogen bond and this intramolecular hydrogen bond. So we all know that the atoms which follow the hydrogen bond, only the fluorine, oxygen and nitrogen, these three atoms mainly show the hydrogen bond and the intramolecular hydrogen bonding. So here in our option there is fluorine, right? So we can easily cancel out methyl chloride, OMe. Why OMe? Because not oxygen, there also a bulky group attached to this, that is methyl. So apart from this, just looking up to the question, our options, we can say there's a fluorine. Yes, the structure would going to be like that. If we write the cyclohexane structure, just axial position fluorine will show the hydrogen bond very good, like this. Okay, so only this in this position, this molecule will be a stable molecule. So our correct option will be what? Yes, this is option B, 2. So who are giving the option 2 is the correct option? Mohammad Kalibullah, but please cover full enjoying math, but please cover more number of questions. Yes, definitely, Mohammad. We will regularly in this week, we will consider so many questions here. Obviously, just follow our channel, okay? You will definitely, it will be helpful for you. Okay, so let's move to the next question. The next question is, obviously, it is also from the organic part. The major product formed in the following reaction is or are is what? You have given this kinds of a chloropyridine compound, and there is the reagent used, sodium NaNH2 and liquid ammonia. So what is the correct option? Anyone? Mohammad Kalibullah, definitely. Gayatri, hydrogen bonding between hydrogen and fluorine. Yes, Gayatri, you are right. In the previous question, the hydrogen bond between fluorine and hydrogen is the most strongest bond. So what is the correct option here? Anyone can answer? Okay, so basically I'm going to explain this question. Our correct option will be option number 1, that is A, this one. Now why? Just look carefully our mechanism, okay? So basically this is a question has been asked to where the molecule, the mechanism passes through a benzene intermediate. So how this is formed? When you have been asked like this sodium amide or liquid ammonia, in this presence of this, at first what going to happen? At first base abstraction, or the proton, that is proton through a base is abstracted from the molecule. So basically just look upon our molecule, there are two options from where the proton can be eliminated. That is this option, and the number 2 is this option. There are 2 hydrogens over there, right? So if just look upon one by one, if we abstract this hydrogen, what is going to happen? There comes a negative charge, right? Lone pair of electrons like this. So what is going to happen? Nitrogen also has a lone pair over the atom, right? So due to presence of close proximity or the adjacent atom, they will show a very lone pair repulsion like that. So this will give you a stable molecule. So this path will be cancelled out. So you cannot abstract the hydrogen from this path. So you have remaining only one option, that is this one. Okay. So just follow the mechanism. What is going to happen at first is base abstraction here like this, and we will find the benzene intermediate like that. Okay. So now we have 2 more again options to follow the nucleophilic attack again by NH2. So the nucleophile can attack at first from this carbon atom in the benzene intermediate, and like that, and the bond will rotate, you all know. Over here, negative charge will be over here, and there comes the NH2, and after that, due to presence of a liquid ammonia, the base abstraction, that is also protonation occurs here. That hydrogen will come here, and we will get the compound X. Again, the nextly we can attack the in another option, another position, that is this one, and thus we will get this molecule. So we will get X and Y, and if you look carefully the options, the option A is the correct option, which we already found that. Okay, so this is nothing but this is that benzene intermediate follow the equation, some simple kind of equation where follow the benzene intermediate. Okay, so this is what? Okay, Gayatri, it is B. No, Gayatri, it's not B. It's A. Okay. Okay. So let's move to our last question. This is another organic question. The order of lambda max in the UV visible spectra for the compound A to C is, you have been given 3 compounds like this. Yeah. And so you have to find which is the correct option, the correct order basically for the lambda max. Lambda max order, basically UV visible lambda max order for this molecule. So which is the correct option? Anyone can want to answer this question? This is very, very important concept. This is also have been asked in this question. Muhammad Kalibullah Abdullah, BAC order. BAC means the option B. Anyone else? Muhammad asked that BAC, homo is greater than heteroannular diene. Muhammad also answered that homo is greater than the heteroannular diene. Anyone else? Yes, Muhammad, you are absolutely right. The correct option will be the option 2. That is B greater than A greater than C. Yes, definitely it is the correct option. So to answer this kinds of question, you need to remember one thing. The important concept is with increasing the conjugation, the lambda max always increased. Okay. So here just look upon the molecule. All the molecule mainly takes part in the conjugation apart from the C, except C, right? So here this B, if we find that the base abstraction at first occurs through this position. So there it comes a negative charge, and that will move light here, here, then here, then here. That is maximum possibility of conjugation, right? Then just little move away to molecule A. The C here, if the minus charge comes here after abstracting the hydrogen, so the bond will move here, then here, then here. So it's also takes part in conjugation, but less than B. Okay, and if you look upon the C, the negative charge over here, that will come here, that will take part here also, and no other option is there. So basically you need to know one thing, that is Muhammad also told here, this is very important things. There's the homoannular diene shows the lambda max more in higher order than the heteroannular annular diene. So these all molecules are basically annular molecule and somewhat in homo and somewhat heteroannular. Okay, so if we know that is lambda max directly proportional to conjugation, we can easily answer this question. So our correct option will be B greater than A greater than C. This option B. So option B is the correct option, which shows the maximum order or the more order of lambda max in UV visible spectrum. So students, I think this session is becomes a very useful for you all. You hope you all enjoyed this. Am I clear to everyone, this concept? Refer book for inorganic for basic students like me. Okay, Muhammad, we will definitely refer you or others, the basic inorganic books. Books you may refer, there will be so many books, but the inorganic books mainly you can follow you can follow basically the Puri Sharma, this kinds of books are very good for you, I think so. So R.P. Sharkar is very good book for you all, and these are the very good books. And also in the next class I will also tell you the important books for each topic that will cover your concept. R.P. Sharkar is very good book that will consider every topics is very good explained there. You can follow that book. Okay, so this is what our today's session. Hope you all enjoyed this and it will be helpful for you all. So all the best everyone for your upcoming examination. You have only 7 to 8 days on your hand, right? So just keep preparing yourself, and all the best for you, and thank you everyone.